Okay. Okay, couple of quick things just a recap. This one basically more for the recap. Okay, you all can see my screen. Try to look at my screen. Okay, so okay, some just quick recap. I believe you all remember these things. This one is important. Actually, I just spent a bit of time just to revise. But I think you all by right should be quite familiar already. Okay, so let's quickly recap. Can see it now, y'all? Can. Okay, thank you. Some respond there. Thank you. Okay, so let me see who else is at the waiting room. Anybody else? No. Okay, I'm recording, by the way, so I'll record this thing for you all to see. Okay, so just some quick recap. This one, okay, nothing fancy, nothing new. So we know that, for example, just recap a couple of things and see. Okay, good, good. Okay, so basically what I have here is a voltage buffer. I think you all know very well. So the voltage buffer, your V out, okay, will follow your V in. Okay, so what is the voltage gain? AV. Revision. Anybody? What is the voltage? Anybody? Still trying out some of the things here. Okay, this breakout room quite interesting. Oh, okay. Okay. Yeah, voltage gain is 1. Thank you very much. Okay, so let's. Okay, thanks. Okay, some of you got some response there. That's good. Is voice break? My voice break. Oh, can hear or not? Very clear. Okay, can Mr. Kumar? Maybe you try to adjust a bit your sound. Okay, so let's move on. If you can hear me, I'm recording also. So the gain is 1. So if you are talking about the voltage gain in dB, okay, voltage gain in dB is 20 log. Okay, AV. Okay, so in that case, let me see what's this. Okay, good. Okay, so 20 log AV, this one. All right. Okay, so and of course, okay, so your AV is the V out. Also is V out over V in. Okay, so this one I think should be quite clear to everybody. Okay, my question is, okay, what is if your gain is 1, what is the log? What is the gain of dB when you do a 20 log 1? Okay, anybody? Anyone got any response?
0, right?
Yes, correct. Very good. Thank you very much. 0 dB. Okay, good. Now, the point why I want to bring up this, okay, why I want to bring up this is, okay, hold on. Okay, if you recall your filter, right? Okay, I'm just going to do a bit of the writing here. Okay, remember your filter, right? Got this op-amp component here. Okay, anybody can tell me also what is a revision? This one revision. What is this filter? Anyone? Low pass. Okay, good. Okay, I can see your response there. Okay, good. Yeah, correct. Low pass, correct. Okay, this one V in, right? Okay, now for the low pass filter, if you also try and recall, okay, for the low pass filter, right, if you recall, now there may be a possibility in the test, right? For example, they may ask you to draw the boat diagram. I don't know if you can remember. This one, okay, maybe it's a quick revision anyway. So first of all, maybe let's do so this part here is resembling the filter, right? I mean the op-amp, right? If you see, is the voltage follower part, okay, resembles the thing that I just drew on the left hand side with the voltage buffer, right? So this is called an active low pass filter. Maybe I write down just a active, yeah, okay, LPF, okay, low pass filter. The reason why it's active because it uses the op-amp, operational amplifier. Okay, so we know that the formula for determining the cutoff frequency. I hope you all recall this. All these things that I'm putting up is very important. What is the formula? 1 over what? Anyone? What is the
Pi square root.
The cutoff frequency?
2 pi.
1 over 2 pi. Correct. Thank you very much. 2 pi what? RC.
Root.
Is it correct? Anyone?
Square R1, R2, C1. Sorry, C1, C2.
The one is the center frequency, is it? You're talking about? You go and check. The one you are referring, I'm not sure who is that. Sorry, the one is a bandpass, right? You refer first, please check. This one is the low pass. Double check. You got your notes or not? If you don't have notes, can refer. Also, put my notes beside me, so that it's easy to make reference. If you have your notes, it will be easy. Make some reference. Just revision, this one, just a quick revision for the op-amp. Okay, it should be in your notes under, let me see, topic, on the filter. Let me point to you. Before the, let me see, reliability, or slightly after the reliability. Can you all find your notes? I don't know whether you all maybe got print out, I'm not sure. Refer to your notes. Wait, let me try to get the page for you. Because we also got a couple of the work example we need to consider. Yeah, filter. Here we are. So if you look at your filter topic, okay, today we have full class. Okay, good. Yeah, so the diagram, okay, why am I bringing this thing up? Okay, because I need to ask you to draw it, because if you look at it, for filter, there's one thing is quite important. You all need to learn how to draw this thing. Okay, you need to draw this thing called the boat plot. Okay, so which means it looks something like this. So this is the frequency, right? First. Okay, and then this one is the dB. You all remember this one? Can you all see? This one is from your notes. Okay, this is from your notes. Okay. Yeah. Okay, how do we draw this thing? This is a low pass filter, right? Low pass filter. So how do we draw? Anyone? So you would expect you to be able to draw, oops, let's go back to here. Okay, you should expect to be able to draw this. All right, for the low pass filter. Okay, for the low pass filter. Now, the reason why I'm showing you this, why this 0 dB, right? Actually, this 0 dB is actually this part here. I'm not sure if you notice. And this part here is the minus 3 dB. Can you see? The minus 3 dB. Now, from the minus 3 dB point, right? If you draw down, okay, this is your cutoff frequency. This one. Okay, so it's all in your notes. You can find this. So I'm just trying to show you that if you see carefully at the top here, okay, this part is the buffer, the voltage buffer. Okay, this part is the voltage buffer, which gives a gain, okay, a dB gain of 0 dB. You all see? It gives the gain of 0 dB here, this part here, which is resemble the voltage buffer on the left hand side. So therefore, this part here, that means during the frequency, there's no amplification. The gain is constant. 0 dB. That means 0 dB means the gain of 1. Okay, in log scale. This part. You see the point? I hope you all can see. So you always minus 3 dB point down. Okay, you draw a minus 3 dB point down, then you extend this line vertically. So this part here will give you the cutoff frequency. Any question on this one? Any question? Anyone? Very quickly. Question? Anyone? Quite easy, this one. Okay, so this one is just a simple recap. So likewise for the high pass filter, you do the same. You must be able to sketch. This one is important. So you want to take note. This one is important. This is just an example for the low pass. So you expected to be able to draw also the high pass one, HPF. Okay, HPF, and also the band pass filter. Okay, so you should be able to draw. It's all in your notes. It's all inside your notes. Okay, it's good. Any question? Anyone? No question? So far, so good. So far, so good. Okay, good. No question. No question means not sure. I hope it's good. Okay. All right. Okay, I think somebody left the room. Never mind. Okay, so let's move on. Let's move on a bit. Okay, can. If not, I will. The screen will be recorded. I think not a problem. The screen will be recorded. And I just now went to do the setting for the Zoom. I think you should be able to save my drawing. This drawing will be saved as a PDF. Okay, so all will be made available for you at the end of the class. I hope the PDF one, can't promise, but I think it should be there. But if all else fail, right, the video recording is there for what I've just illustrated. Okay, so Ken, if any question before I clear the screen. So if I clear the screen, we go to the next part. No question. Okay, Ken. Okay, good. Okay, let's move on. Okay, let's clear the drawing. Okay, let's start again. Okay, so for the case of the okay, quick one. So for bandpass filter, Okay, for bandpass filter, just a quick revision. Okay, BPF. So you all recall in the previous lesson. Okay, so basically now, often a question student asks is whether can you put, you know that the bandpass filter is made up of two filters put back to back, right? So what I can draw for you, this is what we call the block diagram. Okay, so in effect, you can cascade. Okay, the word is called cascade. It's a fancy word. Cascade means join. Join together. Okay, so it means the same thing. Join together. Right. So cascade means to be joined together. Okay, so if you have two filter, one low pass filter, one high pass filter, you can put together. You can put them together, and it will form you a band pass filter. Okay, wait now. Hey, wait now, Mr. Hari Kumar. Hey, God, sorry, just hold on now. Mr. Chan just text me. Just a moment, guys. Mr. Chan just text me because now they are having the practical test there. Just a moment, ladies and gentlemen. Sorry about this interlude. Mr. Chan asked me for something. Let them be. Okay, this student Hari Kumar cannot log in. Okay, never mind. Okay, let's move on. Okay, so basically for the bandpass filter, alternatively, what you can do is you can also design your bandpass filter, right, using the same, the very same filter that you have, but you can reorder them, and it means you can do like this. Okay, you can do this way. Okay, these two also are so-called equivalent. When you do this, right, both are considered as bandpass filter. They are the same. Okay, so in other words, same effect. The same. All right. So, and of course, this is called the block diagram. Okay, this is called the block diagram form. Okay, this is called the block diagram. But in the exam or the test, right, sometimes they ask you to draw the circuit. Okay, in tests, they will likely ask you to give circuit diagram. Okay, they may give the circuit, it depends. All right, they may give you the circuit diagram and then do some calculation. Okay, this one is quite important part. So circuit diagram is something like just now the one I drew. So just now I drew this one, right? You all told me correctly, right? This one. Okay, so this is consider a circuit diagram. Right. So this one is a low pass filter, for example. So you may be able to cascade, okay, or you can combine. Let's say if I combine two, something like this. Okay, so something like this, all right? Quite simple. Sorry, minus, plus, yeah, okay. So something like this, right? So basically you have a low pass and high pass. Okay, so combine you will get this whole thing is a bandpass filter. Okay, and also the other thing is for the bandpass filter, you also need to remember how to recall how to draw the book diagram. So it will be something like this, right? Okay, something like that. This is just a sketch. This is just a sketch. Okay, so this one is 0 dB. Quite easy. I think nothing fantastic. It should be quite easy. So you will take the -3 dB point. Okay, take the -3 dB point, cut at both sides, then you extend the line down. When it cuts this part, right? Okay, you cut this and this. Oops, sorry. Oops, got the thing missing. Okay, now we draw this part. Okay, quite sensitive. The pen. Okay, like that. All right, so you have your maybe FC2, FC1, something like that. Okay, then you apply just now the formula. Just now, one of you say the square, to find the Q factor, you need to find the F center first, right? F center. Refer to your notes. Refer to your notes. Cannot show you. Quite difficult to be able to show everything. But everything, whatever I show you here, is reference to your notes. Okay, inside your notes. So you need to calculate the F center, right? Then you know what is the bandwidth, right? Okay, so bandwidth is FC2 minus FC1 modulus. This one means it's an absolute value. This one, all right? And then you can do the F center. How you calculate F center? You don't remember? What is the formula? Something square root one. That's how you all say. Square root, right? What's the formula? Anybody can recall? F square root one. FC1 times FC2. Right, something like that. Sorry, my 2 cannot come out. 2. Okay. FC1 times FC2, right? To get the F center. And then finally the Q, right? To determine the Q. What is Q? Q, the quality factor, Q factor. What does it do? Q, what is the Q? Anyone? Maybe pause for a while. Anybody? What is the Q? Q, anybody? Yeah, correct. Thank you very much. Jing Jie, Mr. Go. Yeah, F center divided by the bandwidth. Okay, correct. So, okay, good. At least some of you can remember F center divided by the bandwidth. Okay, so what does it mean in, let's say, short, what does it mean? What is Q? What is Q? If Q greater than 1, yeah, what does it mean? What can you comment in terms of the what do you call it? The filters response. Q is greater than 1 means what? So that means if your Q, okay, if your bandwidth is large, imagine if this is large. This message going on. Oh. Okay, so coming back to here. So if your bandwidth is very large, okay, if your bandwidth is very large, okay, your Q will be small. You see what I mean? Your bandwidth is at the bottom here. Damping effect. Well, yeah, you can sort of say that. Okay, thanks for your contribution, Mr. Clarence. Okay, so if your Q is you see, basically your Q is inversely proportional. This is an inversely proportional sign. If I see my bottom here, okay, Q is inversely proportional to the bandwidth, right? So in other words, if you see this expression here, how to get the color? Just trying to think. I'm not sure if this can give you the color. Oh yeah, correct. Okay, you see this one, right? Ladies and gentlemen, okay. So you see here, okay, your F center, the Q is controlled also by the bandwidth. So if your bandwidth is very large, right? If your bandwidth goes up, right? your Q will be reduced. Do you see the point? Yeah, so your Q is inversely proportional to your bandwidth. So the point is that okay, if the bandwidth goes up, right, if the bandwidth is large, your Q will be small. So it means that if your Q is a small value, imagine if your Q is less than 1, it means that this filter is very narrow. Okay, the bandwidth is very narrow, very tight. Okay, as compared to if your Q is large, it means that vice versa, you know what I'm saying? If your bandwidth is large, your Q will be small. Okay, and vice versa. If your bandwidth is small, then your Q is large. So it means that your filter has, sometimes we may not want a bandpass filter with very large bandwidth, which is no good because you allow all the different frequency to go pass through. That may not be what we want. Okay, so yeah. So if you think about in the past, when we use filter to filter out, like maybe the FM radio signal, right? Yeah, you want a decent filter, okay, of a considerable bandwidth, not too much. Okay, because you allow too much, if it's too broad, then a lot of noise also can pass through. Okay, which is not ideal. Okay, so I think maybe with that sort of a damping effect, okay, you can consider yes, okay, which is good. All right. So with that, any question? This one quite clear cut. Some of you find it quite easy. This one. Okay, let's move on a little bit. Now what's the time now? 7 o'clock. 7:15. Okay. You all got any question? Anyone got any question to ask? This one filter quite important. I will tell you. This question is quite easy. But I recommend that you will try to do some of the tutorial question inside. Okay. So can scroll down, cannot see. Which one cannot see? The bottom part, is it? Oh dear. Which part cannot see? Mr. Sharu, the bottom, this part, is it? Because of the what, right? The, how to say? Oh, okay. Below the graph, this part, the Q one, is it? Yeah, okay. So sorry. Maybe it's, yeah, this part, yeah, that's the problem. Because of the control bar, right? Not see. What should I do? Maybe I redraw this part again in the next empty slide. Cannot. Yeah, I'll do that. Is it okay? I redraw this part again on the next slide. A bit cluttered here. A bit cluttered. A lot of things here. Sorry about that. Okay, I'll redraw again. Thanks for the comment. Okay, let's do that. Okay, let me clear this thing. So you all roughly got the idea, main idea. Okay, let me clear this one. I'll redraw on the next piece. Don't worry, I hope because I did the setting, I hope the Zoom will be able to convert, okay, whatever I've drawn just now on this thing into a PDF file together with the lecture video recording. So you may have everything. So I hope so. Because I went in to do some setting. I save it as a PDF, whatever I draw on the whiteboard. Yeah. So today I got a new little tool here. I got my iPad. And also I got my pencil, the Apple Pencil. So I quite nice the experience, the writing. Okay, so yeah, so we see how it goes. Later we will give you the recording as well as the PDF thing that I've written here. Okay. All right. Okay. Let me clear this part first. Let's clear again. Okay. Let's redraw just now the part. You also cannot see, right? Yeah. Thanks for that. So let's help you out again. So I just redraw this part. Okay, the filter response. Oops, sorry. Okay, so it looks something like this. Right, 0 dB. Okay, so you have this 2 point. And this one is the -3 dB. All right, so this is the AV, this is the frequency. Okay, so basically just now what I was sharing was that Okay, rewrite this part, F center. I try not to make it, I try not to write at the bottom because I think you all cannot see at the bottom. Okay, thanks for that. So it's your FC1 times FC2, right? Then your bandwidth, okay, is your modular sign. Now notice I write the modular sign. If you all recall, what is this modular sign? Modular sign means it's the absolute value. Okay, this symbol is called the modular sign. These two symbol here, two bar, two particle bar to say that it's an absolute. That means you cannot have negative value. The bandwidth is a positive value. Okay, so when you subtract out, any negative sign will be cancelled, will remove. Okay, because of the modular sign. So Q is your this F center. Okay, divided by your bandwidth. Okay, the modular sign. This is just the modulus. Okay, means is positive values. So just now what I was saying that if your Q is inversely proportional to your bandwidth. This symbol means inversely proportional. Okay, inversely proportional. I think you all maybe you all know. I don't know. Maybe not. Inversely proportional. Okay, so it means that your, okay, let's move this up a bit. So if your bandwidth increase, your Q will reduce, right? If your bandwidth goes up, bandwidth increase means it's a very broad signal, right? And your Q will be small. If your Q is less than 1, if your Q is less than 1, it means that your filter, your bandpass filter, this bandpass filter is broad. Okay, it means something like this. If your Q is less than 1, it means your filter very, very broad, something like that, the response. Okay, if your Q is greater than 1, all right, because if your bandwidth goes up, your Q will be reduced. All right, you see the inverse proportional relationship. If your Q bandwidth very large, that means imagine if I increase this bandwidth up, your Q will come down. So if your Q is less than 1, that means that this bandpass filter is a broad one. Okay, so if your Q is greater than 1, what does it mean? Greater than 1 means, if I use another color, Q can be used. Yeah, Q will be, you will be asked to calculate Q. Let's say if your bandwidth goes down, your Q will goes up. Okay, you see what I mean? If your I used another color, there are two different conditions here. If your bandwidth goes down, your Q will go up. If Q goes up, means that your Q could be greater than 1. Okay, or in excess of 10, more than 10. So that means that your this bandpass filter is narrow. Okay, so I think, okay, now if you are not clear, right, you may want to refer to your notes, which I think is explained. Yeah, correct. If your Q factor of 1 or smaller is considered, oh, sorry, it's the other way around. Okay, I made a mistake. Okay, if your Q factor of 10 or more is considered narrow, that means, yeah, 1, that means greater than 1 or 10. Can be greater than 1 or 10. If you see your notes, you want to refer to your notes. Yeah.
Iya, sebelah timer tu apa benda? Yang wing timer.
Okay, somebody got the audio side on, so I might have to mute somebody. Sorry about that. Mr. Pani, okay, can. Okay. Any question? Okay, you may want to refer to your notes under the bandpass filter section inside your notes. Okay, it says that I read to you. I'm referring to the notes. Okay, it's taken from your notes, nothing new. I just show you. Okay, so under this part here, okay, that has been explained. You may not be able to see very clearly, but I just point to you, point to the camera. This part here. Okay, so it says that if your bandpass filter with a Q factor of 10 or more, it is considered a narrow, which I will just draw and show you, and it's considered a narrow filter, narrow bandpass filter. Okay, and conversely, if a bandpass filter with a Q factor of 1 or smaller, okay, it is considered a broad or a very wide. Broad or wide is the same thing. This is considered very wide. Okay, wide bandpass filter. This one is the narrow. Okay, so I just point to you one more time and show you. I bring this thing nearer to the camera so you all can see. Okay, okay, can you all see? This one is mentioned here. Okay, in the notes, this is the note. No magic. This one is from your notes one. Okay, can? Okay, so this is something that you want to take note. Oh, this one. Can? Okay, good. Some of you responded. Yeah, the Q can be used for calculation. Usually is what we call the HOTS question. If they ask, you all know what's HOTS question? You all know what's HOTS? HOTS. HOTS question. What does it mean? Excuse me. What is a HOTS question? Anybody? Some water. Anybody know what is HOTS? Anyone? Don't know. You all don't know, right? HOTS. Okay, HOTS stands for what? Okay, so just to share with you, high order thinking type of question. Okay, so the question may ask you to to differentiate the student. Those are A student, maybe the AD or the A student from the B or the average student. Okay, so this sort of thing sometimes may ask. So just want to take note. Okay, I think I cover at least some revision for you guys. Okay, I'm not sure whether y'all got try to do the tutorial. Maybe y'all can also start looking at some of the past papers if y'all have time. But I know today y'all quite fixated, right? Y'all got the 9 o'clock quiz, right? So I think I may not do too much. Okay, so other than that, yeah. Okay, anything else for now? Okay, can yeah. Okay, for those of you, I don't mind. You all want to go and get yourself your dinner. Yeah, go ahead. Go and eat some dinner. Eat something when you are attending lesson. It's fine. Okay, so it's fine for me. Hey, by the way, you all need to help me to do the attendance poll. If you have not done, okay, please go to the Polymore. Okay, just to take note. Please help to do the attendance poll. Please. do your attendance poll in Polymorph. Okay, thank you. For your lecture, can do first lecture and tutorial. Today ours is tutorial, right? Lecture and tutorial. Okay, please do. Yeah. I think, to be quite honest, for my part, for the test, mine is quite straightforward. It's not going to be very tricky or what. So my questions are pretty clear cut. Okay, so you just need to get your basic all correct. I think it should be quite okay. Okay, for generally speaking. Okay, so you all can look at the tutorial questions. Quite a lot there. Okay, things like quite basic stuff. Find out, calculate the Q factor, the upper cutoff frequency, lower cutoff frequency for the filter, calculate the Q factor, and so on. This kind of thing. Right. So other than that, I'm just looking at the question. Yep. Yeah, quite standard. Quite a standard type of question. Okay. Just looking at the questions here, I don't see very special thing. Okay, maybe just look at one question. Okay, maybe you can. I'll take a picture and send your. Okay, I'm looking at the tutorial 5. Okay, I just take one quick picture and send you. Tutorial 5. Okay, tutorial 5. Okay, this one is sending you you see your WhatsApp. Sorry, WhatsApp. I'm just showing you the tutorial 5. Okay. Okay. Maybe we can look at question 10. One question. After that, I think we will just let you all take a break. Okay. So can I clear the screen? Can I clear this screen? No problem. Right? This one can clear. It will be safe. Not to worry. The video recording is there, and I think at the end of the day, it will be a PDF file. You'll give it to you. Okay, I'll clear this screen. Okay, any question before I clear? Anyone want to quickly say anything or say can type in your chat if you want. Okay, nothing. It's okay. If nothing, then I will clear. Okay, 3-second count. Anything? 1, 2, 3. Okay, nothing. Okay, we'll clear this one. Okay, come. Let's take a look at tutorial. Okay, tutorial 5. Okay. Maybe just do one question. Question 10. Okay, then you all can ask some questions if you all have. Okay, so it says you're given, right, bandpass filter. Bandpass filter. Okay, the pass band. Okay, pass band gain 3 dB. Okay, frequency range. Uh, 5 kilohertz to 100 kilohertz. Okay, so first thing first, part 1, sketch, right? Sketch the frequency response sketch. Okay, short form, I'm going to write short form here. Frequency response. The bandpass filter. Okay, so it's going to be that. of course, I'm going to cut space here, save some space. So part 2, calculate. Okay, so I just use the word find, the same, find the F center. Okay, find the F center and the Q factor. The Q factor. Okay, of this bandpass. I'm just bandpass filter. Yeah, so please take note, I'm not copying the question in full. Please take note. I already sent you all the question already, question 10. I just summarizing the question, so I don't have to write so much. So I leave more space for me to show the working. Okay, then of course there's a part 3. I just want it's a very summarized question. Summarizing the question here. Okay, asking you to find what is the amplitude, right? What is the amplitude? Okay, what is the amplitude and the frequency, and the frequency, okay, of this bandpass filter output. Okay, and then they give you, right? So if they say that, let's say if you are given a signal, I call it F in signal. Okay, the signal is what? 2 volt peak peak. 2 volt peak to peak, 50 hertz. 50 kilohertz. Okay, it's applied to this filter. What happens? Okay, see, right? Okay, I think this one maybe the answer slightly got some error. That's why I also pick it up. Okay, so you are supposed to first of all sketch the frequency response. I think the one not a problem. Sketching the frequency response should be quite clear cut, something like this, right? But take note that the pass band gain is 3 dB, so not 0 dB. Correct. It says pass band gain 3 dB. So this is the pass band. Sometimes the pass band can be 0 dB, right? So for this case, the pass band gain is 3 dB. So it means that here is 3 dB. 3 dB. Something wrong with my pen. Okay, 3 dB. Here. So 3 dB. So if you 3 dB, then you the difference here to here, right? It's supposed to be this one by default is you're gonna minus 3 dB, right? That means here is 0. Because here is stated. Okay, pass band gain 3 dB. Okay, so let's do the quick obvious thing first. So we settle the first part already. Okay, to sketch. This is the AV, this is the frequency. Okay, and it's in kilohertz, right? Kilohertz. Okay, kilohertz. So you're going to be from 5 kilohertz to 100 kilohertz. Okay, something like that. Can see? Okay, so the first part, this part. Okay, this one is this one. Sorry, it's just a sketch. Don't get too carried away with the too perfect drawing. Quite difficult to do with the digital pen. Okay, but we try our best. Okay, calculate the center frequency and the Q of this bandpass filter. Should be quite straightforward. This one should be quite simple. So F center, just calculate square root. Okay, FC1 times FC2. So square. So take out your calculator. Okay, I think it's best when you practice with me, we do this together, right? Get your calculator handy so you can key. Make sure your calculator you get very familiar with how to use it. Okay. So let's do it together. So 5K times 100K. Okay, let's try. So you all try. I take your calculator out, please. 5 to the power 3 times 100 power 3 square root. Yeah. So I get 22.36 kilohertz. So you all go and calculate. I get this answer. 22.36 kilohertz. Anybody got different answer? Any one of you got a different answer? Maybe you can highlight. Okay, so I think no problem. Okay, how about the, okay, same. Okay, good. Sharu say same. Okay, good, good, good. Thank you, thank you. Okay, good. Okay, then proceed lah. Proceed. Calculate the Q. You calculate the rest. Calculate the Q. So bandwidth first lah. Bandwidth. Bandwidth is quickly take 100K minus 5. So it's 95, right? Okay, 95, and then you find what is the Q, which you take F center divide by the bandwidth. Yeah, so 22.36 kilohertz. Yep, divide by your 95. So remember your Q factor is something that is what I call unitless. Unitless. Not sure if got this English word or unitless. Yeah, unitless. Okay, so let's try and do that. Divide by 95. Oh, 3. Yeah, 0.235. This is what I got. I don't know about you. 0. Yeah, correct. 235. Thank you very much, Mr. Platsu, Uma. Yeah, thank you. Okay, correct. Okay, now then the last part. What is the amplitude on the, if the frequency is, okay, this part here. So what is the next part? Okay, this part. Okay, what is the amplitude and frequency of this signal? Because you are going to pass through a filter, right? Remember, this is a bandpass filter. Okay, so technically, you are saying that this signal is being, imagine is a sine wave signal, going to pass through this filter. What is the output? Okay, this signal, do you think you can pass through? Okay, so be careful, because what is given is peak to peak, 2 volt peak to peak. Okay, 2 volt peak to peak. So you have to be careful. So because the sine is a sine wave, right? So if I sketch this thing here, it's a sine wave. Okay, so it's if I draw from here to here, okay, use a different color. It's that means it's 1 volt peak, am I right? 1 volt peak here, because yeah, if it's both, yeah, it's 2 volt peak to peak, but now you are considering the half of it, so it's 1 volt peak. The other volt is another 1 volt right at the bottom. Yeah, okay. So what do we do? Okay. Yeah. So let's see. Okay. Thank you, Sharu. You responded. Okay. So what is the amplitude of this signal? Now, first thing first, ask yourself, 50 kilohertz, right? Okay. This signal 50 kilohertz. Okay. Now this 50 kilohertz is sitting. Okay. Maybe the frequency could be sitting in the middle here. You know what I'm saying? This frequency 50 is probably sitting. I'm just sketching. I'm not saying that. It's just a sketch. So your 50 kilohertz signal is actually somewhere in the middle, right? Roughly speaking. So this signal can pass through or not? Ask yourself. Definitely can, right? Because it is within the bandwidth of the filter. Okay, so that means that this sine wave that you have, the input signal 2 volt peak to peak 50 kilohertz, that can pass through, because your upper limit is 100 kilohertz, your lower limit is 5 kilohertz. So your frequency is sitting very comfortably right in the middle here. Okay, So roughly speaking, so the signal can pass through. So that means you expect the signal to appear. This sine wave will appear output here. Okay, the same waveform, the same signal completely passes through the filter. Okay, now remember the filters don't change the amplitude of the signal. Okay, generally speaking, right? It just allow the signal to either pass through or don't pass through. Okay, so technically it doesn't really change the frequency of the original signal, nor does it change the amplitude. Right, so the signal actually remains the same and it passes through. All right, so okay. So what is the question? What is the amplitude? Okay. Yeah, amplitude. Okay, but be careful because this guy, right? Okay, this one a bit special. Okay, because of the 3 dB. What is 3 dB? Maybe you have to, this one a bit tricky. This is another one of those little hot question. Okay, you have to figure out first. What is 3 dB? Okay, I highlight here. Now you want to take note now. Because of this statement here. Okay. The passband gain of 3 dB. Okay, so first thing first, you must understand what it means by 3 dB. Okay, so you'll know that if, okay, I'm going to write on my paper first. Okay, because your gain 20 log AV. Okay, I might need to extend this to the next page. Okay, how much time we have? Okay, now we maybe can quickly wrap up this question. Now, what is 3 dB? What is 3 dB? Anybody? 3 dB in 3 dB. Remember just now earlier I give you a formula, right? I show you right at the beginning at the voltage buffer, right? 20 log, remember? AV dB, yeah, AV, right? Voltage gain in decibel, AV dB is actually 20 log, the gain, right? The so-called voltage gain, AV. Remember I wrote this some time ago. AV dB. I'm going to write this pretty small here. I hope you can see. Okay, maybe I'll box it up. I'll box it up. This part here. Sorry, maybe a bit cluttered, but we try our best. Okay, I'll put a box here. You remember this formula just now I told you, right? A20 log, right? AV. Remember this? Yeah, correct. V out over V in, correct. So basically, this one is your V out over V in. And you have to consider this one, what is given, because the passband gain is 3 dB. That means this one is 3 dB. You know what I mean? Given the passband gain, 3 dB. So I need to calculate or work out what is my voltage gain AV. Because just now you all mentioned, right? I saw your, yeah, it's V out over V in. Because the AV means V out divided by V in, right? Agree? Yeah. Okay, so I need to know what is the V out, which means that for this particular filter, okay, I need to work out, okay, 3 dB, right? If you know how to calculate, so you find out what is AV first. Okay, so that means you take 3 divided by 20, then you inverse log, shift log. Yeah, you will get the gain. The actual gain is AV. The gain, AV is the V out over V in. I hope you know. This one is the AV. This part is your AV. Okay, which is, if I work it out using my calculator, okay, I get one, I don't know about you, but I got 1.412, let's say. 413. Okay, I get this. The gain, this is the gain. That means that the signal got a bit of amplification. Hey, y'all try to remain in the room. Don't go anywhere. Stay in this room. Then we will get the other class to join us. Later, I'll send them the link. Okay, for the next part. Because at 8 o'clock, I'll just do very briefly on the ADC. A very brief one. Then after 9 o'clock, you all go to your MS team with Mr. Chan. Oh, okay, so finally, quickly, and the last part. So that means that this particular filter has a small amplification of a 3 dB. Okay, that means the signal this time around is a bit different. This signal goes in, it gets amplified a little bit. Okay, at the output of the filter, the bandpass filter, it does a bit of amplification. Not unlike in the earlier case where you have a 0 dB, right? The passband gain of 0 dB. 0 dB means no amplification. It means that that one is a voltage buffer. Okay, so how quickly, and let's finish up this last part. So what do you think is the output signal? So that means your signal one, you need to multiply by a gain of this 1.413. Yeah. You understand what I mean? So that means that if you just now consider the part where your signal is 2 volt peak to peak, right? That means my final amplitude, okay, I call it your amplitude. Okay, I don't know whether, I hope you understand the amplitude, okay, of the waveform, because this one is 2 volt, right? 2 volt peak to peak. So that means you take 2 volt peak, PP times this one, 1.413. The gain, the actual voltage gain. Remember, you don't go and take the dB, go and times the amplitude. It doesn't work. You need to convert the decibel into the voltage gain, then only you can multiply. Okay, so if you multiply this by this times 2, right? Yeah, you get 2.82. I hope you understand. Yeah, which is according to your solution. Okay, which now I WhatsApp you already. Right? So the output of this bandpass filter is the signal output. The AC signal is 2.82 volt peak to peak, and the frequency is 50 kilohertz. Is that okay, ladies and gentlemen? I hope you are not sorry wrong. Yeah, sorry, Sharu. Yeah, your answer for the 9.54. Yeah, don't worry, it's okay. At least you try. Okay, so the output is 2.82 volt peak to peak.
Sir.
Yeah. Yes, question. Who's that? Sharu, is it?
Omar. 1.41.
Umar.
What?
Sorry.
1.413. How to get, sir?
Which one?
20 log.
Oh, how I get 1.1413, is it?
Yeah.
Okay. This one you need to use your calculator.
Okay.
Okay. So what you do is that you take 3 dB. Because your 20 is on this side,
Okay.
so you need to divide by 20 on both sides.
Okay.
To get rid of this 20. You understand what I mean? This 20 you need to bring to this side.
So that means the log.
3 inverse log.
Oh, inverse log. Okay.
Anti-log. Yeah. So you take 3 divided by 20 first.
Okay.
Then you use the shift log or inverse log.
Okay.
You will get this one.
Okay, sir.
Can you try?
Okay.
See whether you can get this one. Very important, this one. You can get this one. Oh, this one. Okay, I hope that clarifies the confusion. Any question? Okay, I think I will take a break here. Something to drink. You all can take a break also. 15 minutes. Okay, we break here. Stay in the room. Stay here.
So that's why you say how to get the inverse log again?
Use your calculator.
I'm using it already.
Using it. I don't know how you all use it. Maybe it's your calculator thingy. You all know how to use it.
Maybe I can try again.
Hello, sir.
Yes.
Hey, the filter design MCQ, the remote learning I finished already, but the picture you show me is still doing.
Still doing.
Yeah, same here.
Maybe I capture a bit earlier lah. Then you all submitted.
No, I
is it,
did
Huh?
Saturday leh, or Sunday.
Saturday.
I
Oh,
did
really,
Sunday. I did
Sunday,
Sunday. Yeah.
Oh, you all got click submit or not?
There is
Yes.
the last page of what 3 question. The one got let me see.
You can check
Just to check, you mean the 3 remote learning that at the one
Polymorph
right? I did the 3 already there.
all done
Yeah, I have all the result also in.
Okay lah, good lah.
So
Any problem?
It captures
Capture what?
screen, right?
Got lah, I send you all capture already.
有上过吗？
应该有吗？ Should be there.
看一下，太多东西。
It's I try already.
The last page, try the question below the 3 question. I press next. There's nothing happen.
Next nothing happen The last, what's the question What did they ask?
I screenshot to you. Okay, I sent to the WhatsApp already.
Oh, on the WhatsApp. Wait, while I'm chatting with you guys, right? Let me also. I think the other class already finished. Wait, let me see.